It starts as sticky sap dripping from a rubber tree and ends up bouncing in an NBA arena. This is how a basketball is made. Every time a basketball bounces, spins, and swishes through the net, you've probably never stopped to wonder what's actually inside it. It's not just air. It's a precisely engineered object built from rubber, thread, leather, and chemistry. And the process behind it is far more complex than it looks. Let's start at the very beginning, the raw materials. The core of every basketball begins with rubber, either natural rubber tapped from rubber trees or synthetic rubber produced in a chemical plant. Natural rubber comes from the sap of Hevea brasiliensis trees, mostly grown in Southeast Asia. Countries like Thailand, Indonesia, and Malaysia supply the bulk of the world's rubber. The sap, called latex, is collected by making shallow cuts in the bark and letting the milky liquid drip into small cups attached to the trunk. At the processing facility, the latex is mixed with chemicals that cause it to coagulate, essentially solidify into sheets. Those sheets are then dried, pressed, and sent to sports equipment manufacturers around the world. Before it becomes a basketball, that raw rubber sheet looks more like a dirty kitchen mat. Not exactly what you'd picture at the NBA Finals. At the factory, the rubber is first mixed with other compounds, sulfur, carbon black, and accelerators in a process called vulcanization compounding. These additives give the rubber its final properties: elasticity, durability, and resistance to heat and pressure. The compounded rubber is then heated and pressed into flat sheets of consistent thickness, ready to be shaped. The first component built from this rubber is called the bladder, the innermost layer of the ball. A bladder mold is loaded with the rubber compound, then pressed and heated under high pressure to cure the material into a perfect spherical shape. The result is a hollow rubber sphere, roughly the size of a large grapefruit, that will eventually hold all the air that gives the basketball its bounce. The bladder is inflated to test its integrity. Any tiny leak or deformity at this stage means it gets discarded immediately. Once it passes inspection, the bladder is deflated and the real construction begins. Think of the bladder like a balloon inside a ball inside a ball. Yes, that's exactly what it is. The deflated bladder is sent to the winding station, one of the most visually striking parts of the entire process. Here, the bladder is placed onto a rotating spindle, and a machine begins wrapping it in incredibly fine nylon thread at high speed. The thread is wound in multiple directions, first around the equator, then at varying angles, to distribute tension evenly across the entire surface. Some high-performance balls use polyester thread, or a combination of nylon and polyester, depending on the target hardness and feel. A single basketball can require several kilometers of thread wound around it before this stage is complete. The winding is what gives the ball its true spherical shape, its consistent bounce, and its ability to withstand repeated high-impact use. A poorly wound ball would bounce unpredictably, which is why the tension and angle of every single layer is precisely controlled by computer. That machine winding the thread? It runs faster than your eyes can follow. Watching it in person is genuinely unsettling. After winding, the ball is coated in a layer of rubber cement, a strong adhesive compound that bonds the outer shell to the wound core. The cement is applied by hand or by machine and allowed to cure for a set period before the next layer is attached. Now it's time for the outer casing, the part you actually touch when you hold a basketball. For professional and high-end balls, the casing is made from full-grain leather, the same type used in premium shoes and bags. The hides are tanned, conditioned, and cut into large flat sections at a leather processing facility before arriving at the ball factory. For recreational and outdoor balls, composite leather or rubber is used instead, more durable against rough court surfaces and weather. The casing material is die-cut into 8 identical petal-shaped panels, a shape that, when assembled, perfectly wraps around a sphere. Each panel is cut to within fractions of a millimeter of the required dimensions. Even a small error here will cause seams to misalign later. 8 panels, that's it. 8 weird-shaped pieces of leather somehow become a perfect sphere. Geometry is wild. The panels are first treated with a backing material, a layer of fabric or foam laminated to the inside face, to give them the right thickness and cushioning. Then the panels are placed around the wound and cemented core, and pressed firmly into position, one at a time. On leather balls, the panels are stitched together along the seams by skilled workers using industrial sewing machines, or, in some cases, entirely by hand. The iconic black channels you see on a basketball are actually raised rubber strips that run between the panels. They're glued and pressed into the seams to cover and reinforce them. Those channels also serve a practical purpose. They give players better grip and make dribbling more controlled. Once all 8 panels are attached and the channels are in place, the ball goes into a pressing mold. The mold applies heat and uniform pressure around the entire ball, bonding all layers together and locking the shape permanently. When the ball comes out of the mold, it's visually complete, but it still hasn't been inflated to gain pressure. At this stage, the ball looks slightly soft and sad, like a basketball that had a rough week. The ball is inflated through a small valve, typically made from butyl rubber, that's been embedded in the bladder from the very beginning. Inflation is done to exact specifications. NBA game balls, for example, must be inflated to between 7.5 and 8.5 pounds per square inch. Once inflated, the ball goes through a battery of quality control tests. The first test is a bounce test. The ball is dropped from a fixed height, typically 1.8 meters, and the rebound height is measured precisely. If the ball doesn't bounce within the accepted range, it fails, and the entire ball is scrapped, not repaired. The second test checks roundness. The ball is rotated in a measuring rig that detects any deviation from a perfect sphere. Even a millimeter of irregularity in the wrong place is enough to fail the ball, because irregular balls bounce sideways, and that's a game changer in the worst possible way. Balls that pass both tests move on to the finishing stage. The surface is cleaned, conditioned, and sometimes lightly buffed to achieve the right texture and sheen for the intended use. Outdoor rubber balls get a rough, pebbled surface. Indoor leather balls get something closer to a premium handbag. Same sport, very different finishing. The brand logo, size marking, and pressure specifications are then stamped or printed onto the surface, usually using heat transfer or screen printing. Official game balls go through additional certification steps, including weight verification to the nearest gram. An NBA-certified basketball must weigh between 623 and 624 grams. The margin? 1 gram. That's less than a paperclip. Certified balls are individually wrapped, boxed, and shipped to distribution centers, where they eventually reach pro teams, retailers, and training facilities. A single professional-grade basketball can take several hours to build, involves dozens of workers across multiple steps, and undergoes quality checks at nearly every stage. The recreational ball you might find at a discount store. It follows the same basic process, but with synthetic materials, automated assembly, and fewer hand-finishing steps. So next time you bounce one down a court, just remember, there are literally kilometers of thread holding that thing together. Respect the ball. From rubber trees in Southeast Asia to a perfectly inflated sphere in an NBA arena, the journey of a basketball is one of the most underrated stories in manufacturing. And now you know exactly how it's made. Now it's your turn. What should we build next? Drop it in the comments. The most liked idea becomes our next video. See you there.